Good morning, scholars. Welcome back to the channel. This morning we're going to be adding and subtracting fractions where the denominators are the same. So they already have a common denominator. So the reason we're doing addition and subtraction in the same video is because this is so simple. Once the denominators are the same, we simply have to add the numerators and put it back over the denominator. So I believe this concept is simple enough for both addition and subtraction to be covered in the same video. Now when we go to denominators that are different, each of those will be dealt with in a separate video, the addition and the subtraction. So once the denominators are the same, so that means we both have 8 in the denominator, 6/8 plus 1/8. All we need to do is to add the 6 and the 1. Add the numerators, put them back over the denominator. So 6 plus 1 gives 7, and we put it back over the 8. Okay? That's how simple it is, because they already have a common denominator. 2 tenths plus 5 tenths, they are both over 10. They both have 10 as the denominator. So we're just going to add the numerators. 2 plus 5 gives 7. Put that 7 over 10. 8 twelfths plus 3 twelfths. They are both over 12 already. We don't have to be worrying about finding the LCM and anything like that. We simply add the 8 and the 3 and we get 11 over 12. Right? Pretty simple. And the same applies for subtraction. Once the denominators are the same, we simply go ahead and subtract the numerators. So 9/20 subtract 3/20. We just take the 3 from the 9 in the numerator, that's 6, and we put it back over 20. Now in this case, this fraction can be reduced. So we are going to go ahead and reduce it. Dividing by 2, 2 goes into 6 3 times. 2 into 20, 10 times. The final answer is 3/10. So when we're adding or subtracting fractions and we get our answer, if it can be reduced to a simpler form, to its lowest terms, we do that. We want to make sure our answer is as elegant as possible. In mathematics, when we say the result is elegant, it means it's as simple as it can be. Alright, so here we're subtracting 14, 17, subtract 5, 17. They are both over 17. 17 is the denominator for both of them. So we know that we simply go to the numerators and subtract. 14 take away 5, that's going to give us 9. So that's 9/17. And that's all we need to do. That's our answer. It cannot, 9/17 is already in its simplest form. It cannot be reduced. 6/13 take away 2/13. They are both over 13. So we're going to go to the numerator and subtract. 6 take away 2, that is 4. 4/13. Alright, so we finished one batch already. Now for this batch here, we're still adding and subtracting, but there are 3 terms, 3 different fractions. Sorry, it's the same principle though. Once they have the same denominator, it doesn't matter how many of them there are. Once they have the same denominator, we're not going to add the denominators. That is a common error, a common mistake that's made. We're not adding the denominators. It's like it's the same pie or the same pizza or cake, whatever you already divided up into 11 parts. So you're talking about 5 of those parts, 3 of those parts, 1 of those same 11 parts. So we're not adding 3 separate 11s. It's one whole cut up into 11 parts, right? So we're adding the numerators though, the slices, and we're putting it back over the total number of slices. So 5 plus 1 gives 6, plus 3 gives 9, that's 9/11. Now we have 6/20th, 2/20th, and 1/20th. They are all over the same denominator, which is 20. So we're just going to add the numerators. 6 plus 2 plus 1, that gave 9. And the denominator is 20. So it's 9/20th. 3/19 plus 5/19 plus 2/19. They all have 19 as the denominator, so we're going to add them. 3 plus 5 give 8. 8 plus 2 give 10. So that's 10/19. Now we're subtracting. It's 3 terms we're subtracting, so we're just going to subtract the first 2 and then subtract the other from that answer. So they're all over 16. 11/16 subtract 1/16, and that answer subtracts 2/16. So 11 take away 1 is 10. 10 take away 2 is 8. 8/16 can be reduced to another smaller term. 8 can go into itself once. 8 can go into 16 twice. The final answer is a half. 8/20th subtract 4/20th subtract 3/20th. They're all over the same denominator, which is 20. 8 take away 4 is 4. 4 take away 3 is 1. So that's 1/20th. And that, of course, is already in its simplest form. 19/30th minus 7/30th minus 5/30th. Alright, so they're all over the same denominator of 30. We're just going to go to the numerators and subtract. 19 take away 7 is 12. 12 take away 5 is 7. So that's 7/30th. Alright, so we're done with another batch. Let's go to the last batch. Here we're still adding and subtracting fractions that have the same denominator. This time, however, they will throw in some whole numbers, but the same principle applies. And that's why I'm doing all of these in the one video, because it's so straightforward. Because they have the same denominator, we don't have to worry ourselves about getting the LCM, because the LCM would give us the same denominator. We already have the same denominator. That's why it's so easy. So what we do, if they throw in some whole numbers at us, we simply subtract the whole numbers and put back that as a whole number, and then just proceed the way we did for the fraction part of it. So it will be 8 plus 5, which is 13, and 3 plus 6, which is 9, and we write back the 10. Remember, we don't add the 10. We've just put back the denominator. We add the numerators. Again, 11 and 5 12s plus 3 and 1 12. So we add the 11 to the 3, we get 14. 5 plus 1 gives 6. Now 6 12s can be reduced. 6 can go into 12. So 6 goes into itself once and 6 goes into 12 twice. The final answer is 14 and a half. Okay, so we have 8 and 6 14 plus 1 and 1 14. We're going to add the 8 and the 1. We're going to get 9. 6 plus 1 is 7. Put back the 14. Don't add the 14s. 7 14 can be reduced because 7 can go into itself once. 7 goes into 14 twice. And the final answer is 9 and 1 over 2. 9 and a half. Now we have the subtractions. We're going to use the same principle. Subtract the whole numbers, subtract the numerators, write back the denominator. Okay? Subtract the whole numbers, subtract the numerators, write back the denominator. So that means 12 take away 10 is 2. 3 take away 1 is also 2, and we put that back over 5. 2/5 is already in its simplest form. It cannot be reduced any simpler. 6 take away 1, that's 5. 7 take away 4, that's 3. Put that back over 9. However, 3 over 9 can be reduced. 3 can go into 9. So 3 goes into itself once and 3 goes into 9 3 times. That's 5 and 1/3. 15 take away 10 is 5. 5 take away 3 is 2. And we put that back over the 11. So whichever form they give it to me, whether they just give you some simple common fractions, the denominators are the same. If you're adding, you just add the numerator, put it back over the denominator. If it can be reduced, you reduce it. Subtraction, same thing. Once the denominators are the same, subtract the numerators, put it back over the denominator. If you can reduce the answer, you do so. If they kick it up a notch and add another fraction, don't be scared. It's the same principle. Once the denominators are the same, write back the denominator, add the numerators, and put it over the denominator. If it's subtraction, it doesn't matter how many of them they line up. Don't be scared of the number of them. You're not going to subtract the denominators, you're writing it back. You're subtracting the numerator and putting it over the denominator. If they mix it up some more, and they throw in some mixed numbers on you, so that means we're not only dealing with common numbers, common fractions, with the same denominator, they also give us some whole numbers in it. Same principle. Add the whole numbers and put it back to the left. Add the numerators, do not add the denominator. Just write back the denominator. Because we're saying it's the same 10 slices we're talking about. The same 10 slices of that one pizza. And we're taking 3 of those slices and 6 more of those same slices. So it's not like you have 10 slices here, 10 slices there. In that case, we'd have to add all the 10s. It's the same thing we're talking about. The same one whole we're talking about. Okay? And that is the point of getting things in with the same denominator. You're talking about the one whole thing. Alright, so those are the basic principles of adding and subtracting once the denominators are the same. It gets a little more technical if the denominators are different. So for those ones, I've done separate videos for addition where the denominators are different, subtraction where the denominators are different. So you can look for those videos and keep yourself abreast. If you have been helped, just comment and say thank you, miss, and share it to others so they can be helped. Share to your classmates, share to your friends, share to your neighbors, share to your relatives, your cousins, your brothers, your sisters, so they can be helped as well. And if you have not subscribed to the channel, please subscribe because you will get access to all our dozens and dozens of videos that will help you in your mathematics courses from grade 4 level all the way up to CSEC mathematics. So my scholars, I'll see you in the next video. Take care of yourselves.